Hello and welcome back. This video will cover section 5.2. It's titled Integer Exponents. It's really like two special cases. We're going to see when we have 0 as an exponent and when we have some negative number as an exponent. So let's look at that first case. We have 0. So it just gives us this definition. That anything to the 0 power, and they specify that a itself, our base, is not equal to 0, that this is equal to positive 1. Anything to the 0 power is positive 1, as long as the base is not equal to 0. That would be 0 to the power 0. And then there's some interesting discussion on what this will be equal to. Depending on who you talk to, you might get a different answer for that question. But we'll focus today on non-zero bases raised to the 0 power. It will always reduce to positive 1. So just to throw a few examples. Part A, 5 to the 0 power will equal positive 1. Part B, we have negative 8 to the 0 power. So be careful here. We don't have the negative in parentheses. We just have the base as positive 8. So this will be negative 1. So negative 1. We'll keep the negative here. For part C, notice the negative is inside the parentheses. So the 0 power is applying to negative 7. This will reduce to positive 1. So if the negative's on the outside, there's no parentheses, it keeps the negative. If it's inside, the negative is deleted. And then part D, we have negative 3 times 2 to the 0 power. So the negative 3 is on the outside, that stays there. 2 to the 0 power is 1. So negative 3 times 1 is negative 3. And then we have some more examples where we have variables, and that will still apply even if we don't know what the variable is equal to, as long as we assume that the variable does not equal 0. That's our only condition here. So t to the 0 power equals 1. Part B, negative k in parentheses to the 0 power. So the negative is in the parentheses, so that becomes positive 1. Then part C, we have negative on the outside times 11p to the 0 power. So even though there's two things happening here, this will all reduce to 1, and then the negative will apply on the outside. We could even distribute that 0 power like we did in our last section and see that as 11 to the 0 power times p to the 0 power. So that'll still give us a positive 1. 1 times 1. But then we would need to apply the negative, which is on the outside. So this is like negative times 1, so negative 1. So if you have 0 as a power, it reduces everything down to 1. Even if we had like a very large number, like 300 billion to the 0 power will equal positive 1. The second topic in this section is negative exponents. So we have our definition from the text. It says if n is any integer and a and b are not equal to 0, then if we just have a single number raised to some negative exponent, A negative exponent basically flips a fraction. It might be better to look at the second definition first, sort of the more general case. Or no, let's stick to this first one, because this one's a little bit different. We have two different numbers here. Um, oh, yeah, let's look at this second definition up here. And then we'll look at the first one again. So if we have a divided by b to some negative power, they're saying that this is equal to b divided by a to the positive version of the power. So the negative in an exponent flips a fraction, flips it upside down. Then you can express it with the positive exponent. So in this first one, where we have just a to the negative n, they're saying that this becomes 1 over a to the positive n, which is like 1 over 1 to the power n, which is just 1 over a to the power n. We can see this as a over 1 to the power of negative n. So we can view it in the form of a fraction, like our second example. It's a little bit easier to see that that will flip to 1 over a to the positive n power. And this is true too if we have different exponents, so that's what the second definition is showing, telling us a to the power negative m over b to the power negative n. It will flip the fraction and make the exponents positive. So b to the power positive n over a to the power positive m. So the fraction flips and the exponents become positive. We can go the other way here too. If we wanted to flip a fraction and express it with a negative exponent, that's also legitimate. So let's see some specific examples here. So part A, we have 2 to the power of negative 3. So we just saw we can flip this to 1 over 2 to the power of positive 3. So it flips the fraction. We can view that as like a 2 over 1. And we saw previously that the third power applies to the numerator and the denominator. So 1 cubed over 2 cubed. 1 cubed is 1, 2 cubed is 8. Part B, we have 3 halves to the negative 4 power. So the negative exponent will flip the fraction. This becomes 2/3 to the positive 4th power. So we can write that as 2 to the 4th power over 3 to the 4th power. 2 to the 4th power is 16. 3 to the 4th power is 81. Part C, we have 1/5 to the negative 3rd power. So we can flip the fraction. This will become 5 over 1 to the positive 3rd power. So we can write that as 5 cubed over 1 cubed. 5 cubed is 125. 1 cubed, 1 to any power, will just be 1. So just 125. And then part D, we have negative 7 to the negative 2nd power. So the negative is inside the parentheses, so it will be applied to the power. So we'll just flip the fraction. That's like negative 7 over 1. So 1 over negative 7 to the positive 2nd power. So this is 1 squared over negative 7 in parentheses squared. So negative 7 times negative 7 will give us a positive 49. So if you have a negative exponent, flip the fraction, and then we can follow our previous rules from there. And this also applies to variables. So a few more examples. If we have x to the negative 6th power, we can write that as 1 over x to the positive 6th power. Just ends up in the denominator. If we have 2 over n to the negative 6th power, well, that will flip the fraction, n over 2 to the positive 6, and then let's apply the power. So n to the 6 over 2 to the 6th power. 2 to the 6th power should give us 64. Part C, we have 3 times a to the minus 2 power. The 3 is on the outside here. It's not on parentheses. It might be helpful to write this like 3 times a to the minus 2. That's like an a over 1 in there. So this would be 3 times 1 over a, the positive 2 power, or 3 times 1 over a squared. And this 3 is like a 3 over 1. So if we multiply this, it will end up in the numerator. So 3, that's a weird looking 3. 3 over a squared. So if you have a negative, it flips a fraction, and then you get the positive exponent. All right, that was it for this section. Short one, just on these two special cases. If we have 0 as an exponent, things reduce to 1. If we have a negative exponent, it will flip a fraction or put something into a denominator. All right, that's it for this video. We'll see you next time.